वेलकम बैक टू द विद्यार्थी चैनल में आपका स्वागत है। टुडे वी आर गोइंग टू टेक द टॉपिक ऑन mensuration. Mensuration is a branch of mathematics which deals with measurement of various dimensions of plane figures and three-dimensional figures. Now plane figures are the two-dimensional figures. Right. As I mentioned, mensuration is a branch of mathematics that studies the measurement of geometric figures and their parameters like length, volume, shape, surface area, lateral surface area, volume, etc. Mensuration basically deals with measurement of areas. Why areas is important? If you say surface area, if you have been to a painting site, whether it is an external painting or the internal painting of a room. Now, if you have the knowledge of surface area of a particular shape, you can easily apply those formulas which we are going to study today to calculate how much paint will be required and how much it will cost you. So basically mensuration deals with surface areas, it also deals with volumes. Now when I mention about volume, it is very simple to understand. Volume, you have seen the milkman giving you 1 liter of milk or 2 liter of milk. So he has a measurement, and that measurement, whether he does it in a cylinder or he does in a different type of container, he has its standard measuring instruments. Now he does not do the calculations, but definitely the calculations are based on per liter basis. So per liter means 1 liter. How much is 1 liter when it comes to meter cube? So what is 1 liter? It is actually 1000 milliliter. 1000 milliliter means 1 milliliter is 1 centimeter cube. So we have all these type of relations and ratios which we'll be able to deal with. So this is going to be a very big topic. So we'll try to cover this in 2 chapters. Today will be the chapter 1. Let us start with various type of plane figures. Let us start with what are the plane figures. Plane figures are closed two-dimensional or flat figures which has a plane shape. Now different plane shapes has different attributes such as number of sides or corners. A side which is a straight line that makes a part of the shape. Corners, or which we can call that as vertex, is where two sides meet. The first thing which comes into our mind is how do we identify these plane shapes or figures? A plane figure is something which is two-dimensional in shape and is closed. Now, how many of you know that plane figures do not get formed by two sides? The first thing, the first thing which is important is a plane figure starts with a three-sided figure. The first three-sided figure which you must have seen is a equilateral triangle. Why? Because it has all the three sides equal, right? And all the angles made by the vertices is 60-degree in measure. So this is the simplest plane figure which you must have encountered with. Let us see how many other three-sided figures are there. So we started with the equilateral triangle. We can see scalene triangle. So why scalene? Scalene means all the three sides are unequal. They are not equal to each other. In equilateral, it was all the three sides equal. In scalene, you have all the three different vertices making different angles. So this is what is scalene triangle. Now coming to another type of triangle, that is isosceles triangle. So what is isosceles triangle? You have two sides equal in length. Third side may not be equal to the other two sides. That means there are two base angles equal to each other. That was isosceles triangle. Now coming to another type of triangle, that is called a right angle triangle. So what is a right angle triangle? Very simple. We have a perpendicular and a base on which the triangle is being constructed. You can see this is the base, this is the perpendicular. And the line joining the perpendicular end to the base end is called the hypotenuse. We have mentioned about Pythagoras theorem in previous videos, which you can actually follow in the trigonometry series. I will put the description in the description box where you can actually go and see what is Pythagoras theorem. So we'll not discuss Pythagoras theorem today. Okay. So these are the three-sided plane figures which we need to deal with today. Now coming to a four-sided figure. So you can see very clearly quadrilateral is a plane figure that has four sides. That is, it has four edges and basically four vertices, which you can say four corners. Now you can see from the figure, the angles which are present in this are the angles made by the four vertices. Suppose if you take a quadrilateral PQRS, you can see very clearly what are the vertices. The angles made at the vertices are angle P, angle Q, angle R, angle S, and the sides will be PQ, QR, RS, and SP. So this is how a quadrilateral looks like. There are many types of quadrilateral. We can start with the trapezium. A trapezium is a quadrilateral which looks like this. It has two parallel sides and two non-parallel sides. Now, the good thing about trapezium is there are not many types of trapeziums. One where the non-parallel sides are not equal. The other trapezium is the non-parallel sides are equal in length. Right. Now coming to another set of quadrilateral, that is rectangle. Rectangle looks like there are two pair of opposite sides equal in length and all the angles at the vertices are 90 degrees. Now if all the sides are equal and all the angles at the vertices are 90, it is called a square. So square is a very basic figure. We have been seeing square in various if you have a tile which is fixed in your home, its dimensions are equal in all the directions. Like we have the length and breadth being equal. Now coming to parallelogram. Parallelogram also is a quadrilateral where opposite sides are equal and parallel. A square and a rectangle is a parallelogram. So why I mentioned it separately, because it need not be 90 degree. The angle at the vertices need not be 90 degree. You can see the example, but the opposite angles are always equal and the opposite sides are equal and parallel. Now coming to another parallelogram which has all the sides equal, all the sides, opposite sides parallel to each other, but still it is not a square. So this special figure is called rhombus. Rhombus has different length of their diagonals. This is called the diagonal 1, this is diagonal 2, and diagonal 1 and 2 are not equal. If they are equal, then that rhombus is called a square. So all the squares are rhombus, but all the rhombus are not square. So we have one more quadrilateral which is left, that is called kite. Kite has the adjacent sides being equal in length, but not like the rhombus which has all the sides equal, but it looks like a rhombus when you look from a distance. We have five types of special quadrilaterals which I just mentioned, in which trapezium is also called as trapezoid. The different parts of quadrilateral and their respective meanings are like the parts are side, angle, vertex, base, height, diagonal, perimeter, and area. Now coming to the meaning of this is what is a side? So what is a side? Side that shares an endpoint are referred to as adjacent sides. Sides that don't share an endpoint are called as opposite sides. How many of you knew that quadrilateral is also called as quadruple or tetragon? Let us come to another plane figure, that is a circle. We have a circle with two dimensions. One is its circumference, which is actually calculated with the help of the only dimension, that is the radius of the circle. So you can see this is a circle and this is the center of the circle, which is the important point, because by definition circle is the collection or the locus of all those points equidistant from the center, and that length, that distance, equidistant measure, is called a radius of the circle. So this is how we are going to cover all the parameters. Now we'll start from the basic figure which we started, triangle. Let us come to the point, the various measurements of a plane figure. So starting with perimeter. So what is perimeter? Basically the measure of all the dimensions which make up the plane figure. For example, if you have a triangle, triangle has three sides. The sum of all the three sides is called the perimeter of a triangle. How do we calculate the perimeter? It's very simple. Just know the lengths of the three sides. Just keep adding it. For example, you have one triangle. This is triangle ABC, right? If the measure of AB is 3 units, say 3 centimeter, AC is say 4 centimeter, and BC has 4.5 centimeter. So what is the perimeter of this triangle? Perimeter of this triangle is AB, measure of AB plus AC plus measure of BC. All this line segment has a measure. Just put the measure 3 centimeter. AC is 4 centimeter plus BC is 4.5 centimeter. Now since all the centimeter are common, we can take centimeter as common. 3 plus 4 is 7. 7 plus 4.5 is 11.5 centimeter is your perimeter of the triangle. The previous question we saw all the three sides were not equal in length. That means it was an example of scaling triangle. So if they are equal, for example, if it is an equilateral triangle, all the three sides are equal and its measure is A, then the perimeter will be very simple. It will be A plus A plus A. That is 3 times of A, 3A. This is very simple. If you have a triangle like trapezium, where you have two sides equal, third side not equal to the other two sides. Say in this triangle ABC, these two sides are equal. So this is called as an isosceles triangle. So if this is an isosceles triangle, the perimeter in such case will be equal to A, that is 2A plus B. So if you know what are the measure of the equal sides and the one which is there in the base, you can just put their values. For example, if this is 4 centimeter, if this is 4 centimeter, and if this is 3 centimeter, then the perimeter will be 2 times of 4 plus 3 centimeter, which implies 8 plus 3, that is 11 centimeter. The perimeter in this case in isosceles triangle will be 2 times of the equal sides plus the unequal side of the three sides of the isosceles triangle. So we have seen scaling triangle, we have just mentioned about equilateral triangle, we have seen isosceles triangle. So we have just left with a right angle triangle. A right angle triangle has a perpendicular and a base. This is your perpendicular, this is base, and this is a hypotenuse. The perimeter will be the simple addition of perpendicular measure plus the base measure plus hypotenuse measure. For example, if your perpendicular is 3 centimeter, base is 4 centimeter, hypotenuse will be 5 centimeter. You can actually verify this by using Pythagoras theorem. Pythagoras theorem. So what is Pythagoras theorem? Perpendicular square plus base square is equal to hypotenuse square. So you see here 3 square plus 4 square is equal to 5 square. All the units taken as centimeter square. So what is 3 square? It is 9 plus 16, which is equal to 25. Left hand side is equal to right hand side. This is how you can verify this is as a right angle triangle. That means the perpendicular and the base meet at a vertex which makes an angle 90 degree. This is the largest angle. If your reference angle is theta, this will be 90 minus theta, which I have already mentioned in my previous videos. So for the smaller class, we have to just keep adding the 3 points, 3 plus 4 plus 5, 3 plus 4 plus 5 measured in centimeter. The perimeter is very simple, just keep adding the measures of the side. 3 plus 4, 7, 7 plus 5 is 12 centimeter. Easier answer for this case. Okay, now coming to the four-sided figures. For perimeter, it is as simple as the three-sided figure. We need to just keep adding the measures of the all the three, like in case of triangle, all the four sides in case of a quadrilateral. So if you take any quadrilateral of any measure, see this is a quadrilateral PQRS. So what we need to do when it comes to perimeter, right? We need to just add PQ with QR and then add it with RS plus SP. See, whatever the measure comes here is the perimeter. For example, if we PQ is 3 centimeter, QR is say 4 centimeter, SQ is say 7 centimeter, right? And this is say 5 centimeter. Then what is PQ? 3. What is QR? 4. What is RS? It is 7. And SP is 5. All in centimeter. I can write this as centimeter common. Put it in a bracket. So 3 plus 4 is 7. 7 plus 7 is 14. 14 plus 5 is 19. 19 centimeter is my perimeter of this quadrilateral. Now, does it make any difference if this is a square or a rectangle? We need to just add it. Only in case of square and rectangle, we can actually formulate, we can have a formula in place, like we can do it in the next slide. But in case of a square, where all the sides are equal, you can see in a square, this is S, this is S, this is S, and this is S. Because all the sides are equal in length. The perimeter in such case, perimeter in such case will be S plus S plus S plus S. That is, you add S 4 times or you multiply S with 4, it is 4S. 4S will be your perimeter of a square. Now, for example, if the side is 2 centimeter, 2 centimeter, 2 centimeter, and this is 2 centimeter. So your perimeter will be in this case 4 into 2 centimeter, that is 8 centimeter. It is as simple as that. Let us take next rectangle. So this is a rectangle. So what is a rectangle? I have mentioned in my previous definitions. Rectangle is a parallelogram where opposite sides are equal and the angle at the vertices are 90 degree. So what is the perimeter of a rectangle? It is, opposite sides. This is called length and this is called breadth in case of a rectangle. So what is the perimeter? It is 2 times of L plus B. Can we see clearly? If you calculate the perimeter, it will be L plus B plus L plus B. Since it is 2 times, we take this as 2 times of L plus B. For example, if the length is say 36 centimeter, right? And if the breadth is say 24 centimeters, The perimeter will be 2 times of 36 plus 24 centimeter. So what is 36 plus 24? It is 60. 36 plus 24, it is 6 plus 4, 10. 1 carry forward, 1 plus 3, 4 plus 2, 6. So it is 2 into 60 centimeter. 2 into 60 is 120 centimeter. This is the perimeter of a rectangle. This is actually a very simple thing to learn or remember, not very complicated. Next plane figure which we'll take is a parallelogram. A parallelogram will follow the same method as a rectangle. Now if you see parallelogram, these two measurements are same. So this time I will not call this as a length and a breadth. Length and a breadth we are normally using for a rectangular figure. Now this is a parallelogram. If this side is A, this side is B, then this side has to be B because opposite sides are equal, and this has to be A. For perimeter in case of a parallelogram, P will be equal to 2 times A plus B. As you see, this is repeated twice, this is repeated twice. So the perimeter will be 2 times of A plus B. Now I need not take dimensions and prove it as we did it in case of rectangles. So let us take the next figure, which is a rhombus. A rhombus, as I had mentioned, is a parallelogram having all the four sides equal, but the measure of the diagonals are different. Now this is a rhombus. This side is equal to this side, which is equal to this side, which is equal to this side. But these are the diagonals. This is called D1, and this is a diagonal which is called as D2. So we have to remember that D1 is not equal to D2 in case of rhombus. So as a special case, if D1 is equal to D2, we don't say it is not a rhombus, but this special rhombus is called a square. So rhombus is a square only when the diagonals are equal. So all diagonals have to be taken into account when we are doing measurement in case of a rhombus. Now here the perimeter will be same, like the perimeter will be same as, if all the sides are equal, we can put that as S, same as square, 4 times of the measure of one side. So this is how a rhombus looks like. Now let us go to the next figure, that is a kite. So the kite looks something like this. Now these two sides are equal and these two sides are equal. So this is a kite. So here one thing is definitely of interest. Here also diagonals are not equal. Obviously this diagonal, if this is D1, this is D2, here also D1 is not equal to D2. Now we have two types of side. If you take this as A and A and this as B and B, then the perimeter will be 2 times of A plus 2 times of B. We can just simplify as 2 times of A plus B. If you know the measure of the adjacent sides, we can always take that as our reference. We can say perimeter of a kite is 2 times of the one pair of adjacent side, measure of one pair of adjacent side, plus the other measure of the other adjacent side. Okay, let us take the last quadrilateral, that is the special quadrilateral trapezium. Trapezium has one set of parallel sides and other two sides are non-parallel sides. So if I write this as AB, CD, so I write this AB is parallel to DC. So if you take in one direction, AB is parallel to DC. AB is not equal to DC for a trapezium. Remember. Similarly, we have two conditions. Case 1, where AD may be equal to BC. It's called as an isosceles trapezium. And case 2 is when AD is not equal to BC. In general, we find most of the trapezium of this type. Now, what is the perimeter in this case? The perimeter is, as by definition, you just take AB plus BC plus DC plus AD. You will get your answer. For example, if this is 4 centimeter, this is 6 centimeter, this is say 5 centimeter, and this is say 6 centimeter, right? The answer will be, what is AB? 4 plus 5, 9 plus 6, 15 plus 6, 21 units. 21 units means, yeah, here it is 21 centimeter. I hope you got an idea about all the plane figures which we have just mentioned. Just left with one plane figure, that is circle. Talking about a circle, a circle is called the locus of all those points equidistant from a fixed point. Now this fixed point is called center. Normally we take center as O, and the equidistant length measure is called the radius of the circle. So what is the perimeter of a circle? If this is a circle, the perimeter of a circle is also called as the circumference. This is measured with the help of a parameter called pi. So it is 2 times of the pi value into the radius. It is also called as pi into d. Here d is the diameter. This is also, the measure is 2 times of r. This we have to remember for in case of circle. Okay, now coming to the next measurement of the plane figures, will come to the area of triangles, three-sided figures, area of quadrilaterals. We'll see if there are some formulas associated with it, and area of circles. We'll start with area of a triangle if you have only all the 3 sides, no other information. For example, I have a triangle. Triangle ABC, right? Measuring the side length of BC is say A units. The side length of AC is B units. You can just put a apostrophe for just identification, and the side measure of AB as C units. The first thing which we need to find out is, we need to find out the perimeter. The perimeter is A plus B plus C units. Now we are going to attempt the area of a triangle where only A, B, C values are available. Now these are all small, in small letters, A, B and C. We need to find out the area using semi-perimeter method. So what is S? S means P upon 2. That will be A plus B plus C whole upon 2. So if I have the value of S, that is a semi-perimeter, then I can use HERONS formula. So what is HERONS formula basically? So to find out the area of a triangle, we can use HERONS formula, which says area is equal to under root of, that is semi-perimeter times S minus first side into S minus the second side into S minus the third side. I'll go by an example. We'll take values which we already know. We'll take, say for example, A has 3 units, B has 4 units, and C has 5 units. So these are not, the figures are not calculated as per the diagram is not made as per dimensions. This is only an arbitrary numbers which I have given. Fine. To find out the area of such thing, first we need to find the semi-perimeter, which means 3 plus 4 plus 5 whole divided by 2. So this is 9 plus 4. So this is actually 9 plus 3, 12. 12 by 2 is 12 by 2 is 6 units. So semi-perimeter is 6 units. Hence, S minus A will be 6 minus 3, that is 3 units. Similarly, what is S minus B? It is 6 minus 4, which is 2 units. And S minus C is 6 minus 5, that is 1 unit. So what will be the area of such triangle? Area of such triangle will be under root of, so what is S? 6 into S minus A, that is 3 units, S minus B, that is 2 units, and that is equal to 1. Now if you can see, it is 6 into 3, 18, 2, 36, 1 is 36. Square root of 36 is 6 square units. So area of a triangle where we don't have any other information other than the measure of the sides, we can use HERONS formula. Continue with the area of triangle using another method. Now the conventional method which you have been studying in the school is if you have a right angle triangle. This is if you have a right angle triangle. That means it's not necessary that you don't have a right angle triangle. You can have any scaling triangle. Then the information required will be altitude and base. So for a right angle triangle, for example, A, B, C, right angle at B, if the measurements are, for suppose this is 4 units, that is 4 units, right? And if this is say 3 units. So for a right angle triangle, this is a hypotenuse which will be 3 square plus 4 square under root of this. So 3 square is 9, 4 square is 16. 9 plus 16 is 25, square root of this is 5 units. So if you have a right angle triangle, then the area of triangle ABC, the conventional method which we have been studying is half into the base, that is BC, into height, that is AB. Now the height is actually the altitude, that is the measurement of the shortest distance. The measurement of the shortest distance from the uppermost vertex from the base of the triangle. Now this is the base of the triangle, the shortest distance is AB and the longest is AC. And the longest one is also called as the hypotenuse if it is a right angle triangle. Fine. So what is base? Base is BC. So this is your base. So you have a formula which is called half into base into altitude. So this is the most conventional formula which we have been using in the schools and institutions. So this is half into base into height. So here in this case we have half into base measures to 3 units and the altitude measures to 4 units. Now, so what is the answer? 3 4s are 12 divided by 2 is 6 units, 6 square units. The best part of this is I had the same dimensions in the previous HERONS formula. We got 6 units as the answer. Please pause the video or you can rewind the video. Go back to the HERONS formula. We had the same triangle 3, 4 and 5 as the dimensions of the various sides. We still got the same answer using a different method. Here we got 6 square units using half into base into altitude. Now taking up the other area formula for triangles, we have a isosceles triangle. Now isosceles triangle has two equal sides which are adjacent to each other and one unequal side which is the base. Here in this case it is a base. So if you use the same formula, half into base into altitude for this triangle ABC, then we need to actually derive an equation which shows area at one side, right hand side will have the formula for this. So we will use only these parameters as the formula. Now these are the two things which will drop down a perpendicular. We drop down a perpendicular. Now you can see if this perpendicular, if this point is D, then triangle ADB, triangle ADB is a right angle triangle. Right angled triangle with 90 degree at the vertex D. So you can see very clearly this is a right angle triangle. If you take this as a right angle triangle, then to find out what is the measure of AD. So what is AD basically? AD is the perpendicular of the right angle triangle. Perpendicular. BD will be the base and AB is the hypotenuse. So in order to understand how to calculate the altitude of this isosceles triangle, we need to just find out, we use perpendicular square plus base square is equal to hypotenuse square. This is your Pythagoras theorem. Now here perpendicular square means it is AD square, which is also equal to h square minus base square. So this is your hypotenuse square minus base square. That means P is equal to under root of h square minus b square. Now what is your h? That's a hypotenuse, that is a square. So we get under root of a square minus, what is this part? This part is half of BC, and what is half of BC? It is half of B. So we get a B by 2 square. Fine. That means AD it measures to. Now you can cross multiply this. What is B square? B by 2 whole square. It is B square by 4. If you cross multiply, it comes to 4a square minus b square whole divided by, if you take the square root of 4 is 2. So you have got AD as 4a square minus b square by 2. That's your PD. Now what is your base? Base is BC. So here base is BC. So you can directly write the formula half into base is B into, the formula is under root of 4a square minus b square whole divided by 2. Now you can see we have taken the altitude as under root of 4a square minus b square upon 2. Now if you combine this, you get the final formula as b times of under root 4a square minus b square whole divided by 4 square units. Now we will take one question on this and you will get an idea about it. The formula for the area of an isosceles triangle where A is the measure of the equal side and B is the only unequal side, then the formula of area will be B times of under root 4a square minus b square upon 4 square units. Let us take an example of an isosceles triangle with this has 3 centimeter and these two has 4 centimeter each. Now this is A, this is B, this is C. So what is the measure of A? It is 4 centimeter. And what is the measure of B? It is 3 centimeter. Now if you know this formula, the area is going to be B times under root 4a square minus b square whole divided by 4 square units. Actually, it comes directly. See, B is 3 centimeter. 4 times of a square. A square is 16. 16 into 4 is 64. So this is 64 minus B square. What is B square? 9 whole divided by 4. This is your square units. So what is the value? 64 minus, what is 64 minus 9? It is 55. So you have got 3 under root 55 by 4 square units. We can verify this measurement using Heron's formula. So what is Heron's formula? Heron's formula. For this question, if you use Heron's formula, so what is your semi-perimeter? It is 4 plus 4 plus 3 divided by 2. 4 plus 4 is 8 plus 3 divided by 2 is 11 by 2. So what is S minus A? It is 11 by 2 minus 4. What is S minus B? It is same as 11 by 2 minus 4. So what is 11 by 2 minus 4? It is 3 by 2. Cross multiply. 11 minus 8 divided by 2, that is 3 by 2. This is also 3 by 2. What is S minus C? It is 11 by 2 minus 3, which means 5 by 2. See, 11 minus 6, that is 5 divided by 2. So we have all the values present. We have to just extrapolate that value here. So what is, this is 11 by 2 multiplied by 3 by 2 into 3 by 2 into 5 by 2. Now, you can see for yourself, 11 and 5 cannot be, you cannot take a perfect square root out of it. So it will remain inside. It will become root 55. 2 into 2 into 2 into 2, that is 4, 2, the 8, 2, the 16. The square root will be 4 and the square root of 3 into 3 is 3 square units. So we have got identical values. Can you see? You have got 3 root 55 by 4 square units by the new formula which I have given you and the Heron's formula which we studied in the beginning. We have corroborated the information. I hope you understand this. Please pause the video and you will be able to do that question by yourself and then check whether you are getting the same answer. Now we will take one triangle which is called equilateral triangle, and here the equilateral triangle we know that has all the sides equal. So we attempt the equilateral triangle using both methods. One half into base into altitude, other one is Heron's formula. So I will put the equilateral triangle in the center. We know all the sides measure the same, A and A. This is A, this is B, this is C. This is an equilateral triangle. So equilateral triangle means the semi-perimeter will be A plus A plus A divided by 2. That is equal to 3A by 2. So you got the semi-perimeter as 3A by 2 units. Now, what is S minus A? 3A by 2 minus A. So see, this is, if you take A common, it is 3 by 2 minus 2 by 2. So you can put 1 as 2 by 2. So you will get A by 2. Similarly, what is S minus B? It is equal to S minus A, which is equal to S minus A, which is also A by 2. So what is the area of an equilateral triangle using Heron's formula? So we are taking Heron's formula on the right hand side. So if you see very carefully, the area of the triangle ABC equilateral will be equal to under root. Take S. What is S? S itself is 3A by 2 into A by 2 into A by 2 into A by 2. Right? So we have 4 times A, that means A square comes outside. 4 times 2, that means 4 comes outside. 3, the square root of 3, it is an irrational number, so it comes as it as into root 3. Or you can simply write this as root 3 times A square by 4. Square units. Now we will attempt the same question using half into base into altitude. So I will drop down a perpendicular. Now perpendicular in case of an isosceles triangle or a equilateral triangle divides the base into equal parts. So what is the measure of this? BD. BD will be A by 2. Now this is A, this is A by 2. So altitude AD will be equal to under root A square minus A square by 4. So this is actually equal to 4A square minus A square, that is 3A square by 4. So you take the square root, it becomes root 3A upon 2 units. So this is your AD, which is also the altitude. So the altitude AD is root 3A by 2 units. So what is the base? Here the base is BC. It's not BD, it's BC. So what is BC? BC is A units. This is your base. So as per the conventional formula, the area of a triangle which has a base and an altitude measure, we can always find the area as half into base, that is A, into altitude, which is root 3 times A whole upon 2. Now if you multiply all this, 1 into A into root 3A is root 3A square, whole divided by 2 into 2 is 4. You can see, we can corroborate this information. We have already achieved this by Heron's formula. So this is the conventional method, and this is your Heron's formula. So if you use either of the method, you are going to get the same value. I hope you understand. Please pause my video, take some dimensions, try to solve this question by any of these methods. You will get the identical answers. Okay, let us start with the area of the four-sided figures, the quadrilaterals. The quadrilaterals will start with trapezium. We'll take trapezium. Right. So what is a trapezium? It has parallel sides and non-parallel side. So this is these two sides are parallel, AB, C, D. So here AB is parallel to DC. Right. If you know this altitude, this is called the altitude H. Right. If I go by dimension, if AE is given, then area of a quadrilateral ABCD is equal to. In case of a trapezium, be very careful. These two sides are called as the parallel sides. So what we will say, it is half into sum of the parallel sides. Sum of the parallel sides. Parallel sides. Multiplied by the altitude. Altitude. Now, if I take the parallel sides here, it will be half into AB plus DC multiplied by AE. Right? So this is how area of trapezium is calculated. I'll give you one example. If AB measures 3 centimeters, DC measures say 7 centimeters, and the altitude is say 4 centimeters, then area of the triangle will be, in this case, area of this triangle will be half into sum of the parallel. This is 3 plus 7, 3 plus 7 into the altitude is 4. So 2 ones are 2 twos are 7 plus 3 is 10. 10 into 2 is 20 square centimeter. It is as simple as that. So area of a trapezium can be found out by using the formula half into sum of the parallel sides into latitude. Let us take the simple figures square and a rectangle. So starting with square. Square has all the sides equal. So by definition, what is area? It is the space enclosed between the dimensions, the all the sides. So what is the space? The space which is a measurement, that is called as area. Now we are going to calculate area in case of sides measuring S only. This is a square. So the square, the area of a square is always equal to side into side is equal to side square units. So we'll just take an example. If each measures say 2 centimeter, this is also 2 centimeter, this is also 2 centimeter, 2 centimeter, then the area of such a square which has side measuring 2 centimeter is 2 centimeter into 2 centimeter is equal to 2 2s are 4 and then square centimeter. So this is how we get it. So the area of a square will be just the square of these sides. Let us take another quadrilateral, that is rectangle. So rectangle has a length, that means which is the longer side, and a breadth which is the shorter side. This is how it looks like. The area of a rectangle is very simple. It is the length times the breadth. So if you take an example, if the length is say 4 centimeter and if the breadth is say 3 centimeter, the area will be 4 into 3, that is 12 centimeter into centimeter, square centimeter. Or you can write centimeter square, 12 centimeter square. So rectangle is actually very simple. If you want to find out the area of a parallelogram, area of the parallelogram, see, if you can divide this into two parts, this altitude and this altitude will be same. So if this is one part of the area and this is the second part of the area, so what is the first part? If you say this is A, B, C, D, this is say E and this is F, then in first part you have half into base is BC into height is AE. Right. Similarly, what is A2? Second part, it is half into AB into height is FC. Now, from the figure we know that since these two are parallel lines, AE is equal to FC, which is the altitude. This is common. Similarly, DC is equal to AB by definition. Definition of parallelogram. So what is the definition by parallelogram? AC is equal to DC is equal to AB. That implies I can write this as the base of the both are actually the base of the triangles, respective triangles. So this I can put it as B. Now if you see carefully, so it will be the sum of these two areas. The overall area A will be A1 plus A2. Right. So you see the overall area of a parallelogram is sum of these areas. I can write this as half into, first case is half into DC. DC is equal to B. So half into B into H plus half into B into H. See, these two dimensions are same. It is base into altitude. So area of a parallelogram is simply, if you know the base from where you have actually calibrated or calculated the altitude, then the area of parallelogram will be simply base into altitude. If you take this as base, you need to take this as altitude. You need to find out the altitude in this case differently. So we have taken DC and AB as the base. For that, AE or CF or FC is the altitude. So we will take to the next quadrant. Let us take the area of a rhombus. Now, how does a rhombus looks like? Rhombus looks like this. See, there is one dimension which is different from square, the diagonals. This is diagonal 1, this is diagonal 2. So, area of a rhombus, if you take area of rhombus, which will be equal to half into d1 into d2. I'll take an example of this. If you got d1 as say 8 centimeter and d2 as 6 centimeter, the area of a rhombus will be equal to half into 8 into 6 centimeter square. 8 6 are 48 divided by 2, 24 centimeter square. Without knowing this side measure, we can still find out the area enclosed in a rhombus with knowing only the diagonals. Let us find out what is there any formula for area of a kite. So for kite, you know these two sides are adjacent sides equal in length and these two sides adjacent are equal in length. Now, to find out the area of a kite, we need to know all the dimensions including the diagonal D2 or the diagonal D1. Why it will help? Because we can calculate using HERONS formula. So there is no particular formula by just knowing the sides of the kite. So you can use HERONS formula based on whatever information is being provided in the question. So based on that, we can do, for example, if I have the measure as AB is equal to AD, which is equal to say 4 units, 4 centimeter, and BC, which is equal to DC, is equal to say 5 centimeter, right? And if BD is provided as 3 centimeter, then the area will be half into base. So base is 3 centimeter into your height. For that, we need to use the formula to find out what is the measure of, suppose this is O, we need to find out AO for the upper part, right? The upper area, and for this is your AO, and the second part is half into the the base is say 3 centimeter. Here comes C. So if you know both the values, you can just add it. This will become A1 plus A2, which is your required area. Half and 3 are common, that is half into 3. Half into 3, that means the base into the measure of AC. Now what is AO plus CO? It is AC, which is the measure of D1. So if you know the measure of D1, we will be able to find out the area of kite. Kite is actually based on whatever information provided, we need to use the respective formula. For area of circle, see, for a circle, we need to know the radius, the measure of radius. The area of a circle will be A is equal to pi r square. Thank you for watching our videos. I hope आपको आज का वीडियो पसंद आया. I think that things were very clear in this today's videos. If you have any queries or if you have any suggestions, write down your suggestions in the comment box. For the previous videos, I will put some links in the description box. Kindly go through that. And if you have not subscribed till now, please make it a point to subscribe and press the bell icon. Thank you very much for watching our videos. Shabak hai.